November 20th. Just raked the coals out to relight in the greenhouse here. Cricket is serenading me from under the stove. Aren't you, buddy? My little cricket pal. He keeps me company when it's cold and nasty out. He sings me a nice little serenade every night when I start the stove. So while I'm in here, finally got around to doing some watering on the plants. So I had to refill the tanks. I actually took warm water, now that it's not hot water, from the secondary thermal mass tank to do the watering. Refilled that, took about 20 gallons of cold pool water to refill it. And I also topped up another 5 gallons and probably another another total of 7 gallons in here to top the big tank on top up. And I just thought this is a good opportunity to look at the charts here. You can see after I finished insulation last night, even though temperatures were climbing steadily outside, still it was fairly cool out. And you can see how much more steadily the greenhouse temperature stays here, and how actually we weren't losing heat out of the thermal mass till much later on in the cycle. And you can see where I brought the pump on manually here this afternoon just to dump the heat from the upper thermal mass to the secondary tank. And then over here you can see on the BTU charts where I added cold water to the tanks, you can see them basically drop vertical. Boom, boom. So we're down to about 25,000 BTUs in the bank at the moment because of the cold water addition. Maybe I'll grab another clip of this in a couple of hours when it starts to come back the other way with the stove fired up. Just wanted to catch a clip of that and point out some of the trends that show up as a result of ongoing operations in the greenhouse. Alright, here we are out on the back side of the greenhouse. And you can see 4-inch, 4-inch, 2-inch, 2-inch, 4-inch insulation panels in place. Those are tucked in between the two layers. That keeps them nice and stable in position. I've tightened them up between the seams of them as well as best I can, given the terrain. Same here, there was probably a 4 or 6-inch gap between these two now. They're pretty close. And then I came back here with the tractor. I've been pulling wood chips. These wood chips are pine and spruce, and they just really screwed up soil in the plot that I put them on. So I'm not putting them down for mulch. So I decided to use them for another use. I thought they would make a great berm on the back side of the greenhouse here to kind of pin this insulation in place and seal this up and give another layer of insulation on the north wall here. Obviously I have to come back here with a rake and shovel and kind of touch it up a little bit. I don't want to destroy the greenhouse, and that 5-ton tractor, man, all it takes is a little flick of the bucket or a little dump of the clutch and you could just bulldoze the whole greenhouse right over, so I don't want to do that. So I got as close as I could and got it filled in relatively well. I'm probably going to push this in by hand a little bit, and then I'll probably berm this up a little bit thicker and taller in here. Probably come just shy of the vent here. So this whole back wall will be well insulated and sealed, and this should keep us nice and toasty over the winter. Should make a big difference in the temperature in the greenhouse. What I'd love to do, of course, is have a greenhouse that's recessed in the ground, but you know, it's a little late to do that now. So this will make a good substitute for that and provide a little bit more protection against winds and cold and such. The upgrades continue. The heat pump is on right now. We'll take a look at the chart. Alright, so earlier I showed you last night improvements since the insulation went in. I'll just let you look at the scale on the chart here so you can see the temperatures and BTU values. And you come over here and you can see where I lit the stove up. You can see the stove temp climb out from that point, and you can see where I opened the vents to air the smoke out. You can see that temperature drop in the average greenhouse temperature. And this is the blue line here is outside temp, and this brown line down here is deheat or delta heat. In other words, the difference between reservoir 1 and reservoir 2 for thermal mass for management. I have not implemented deheat into the script for controlling the pump yet, but that's going back in soon. What else? This is, yeah, average greenhouse temperature. This is a secondary thermal mass temperature, average temp between the high and low sensor. So that's sitting a little over 90 at the moment. You can see that looking at the top line here. Hey Brad, you're always here. I love it. Check out Grow the Farm Up if you haven't. Grow the Farm Up! And check out our interviews on Comrades and Farms. Very interesting guy. Anyway, that's just awesome timing. You can see the stove temperature climb and drop, and you can see the upper reservoir climb and drop when the heat pump comes on and pumps heat into the second reservoir, which you see here. And I'll kill those notifications so you can actually see the BTU chart here. You can see where the top tank dumps to the bottom tank. So you see those two like invert their temperature shift in BTUs. This is expressed in BTUs. And then the top line is total BTUs. So you can see that steadily climbing, and a little bit of variation there because of the way the sensors are set up. But pretty much very right on. That always tells you that you have good calibration on your calculations for gallons, which ends up being your calculations for BTUs ultimately. That's important if you want accurate data. And here at the Pharmacy Seeds Network, we're all about accurate data. That's important. Alright, I'm off my soapbox. Hope you enjoyed. So here we are outside the greenhouse, and it's time for new headlight batteries, looks like. But I showed a clip before, which I'll throw in here quick, of filling the back of the greenhouse in here. Pardon me, I'm tripping over all kinds of stuff. Filling this in with the wood chips to tighten this up to help hold that insulation in place and provide another thick layer of insulation. Just for starters. Now I think what could be done if you wanted to is you could take and put a layer of chicken manure over this, and then that nitrogen would accelerate the decomposition of this pile of wood chips, and the heat from that would basically be a heat bank in the back wall. I'm not going to do that for now. I just want to fill this in and give us a really nice insulation layer, seal up any air leaks that are going on. We've had some rodents infiltrate over the years. This greenhouse is now 6 years old. So it's time for some upgrades and some maintenance. So I got over to here. I was just going to do the back wall, and I realized that this end of the greenhouse has sort of been neglected. I'll just show you real quick here. This is where the in-ground furnace used to be. That was 4 feet in the ground, and there was an exhaust tube that came up and went to a Y. So for startup, I could come out a vertical pipe right over here off to the side, and that would let me get the temperature of that furnace up, and then I would close that off, and I would send the exhaust heat out through this 4-inch tube all the way around the floor of the greenhouse. That was the original setup for this greenhouse. It was basically just a test. The materials I had I knew weren't up for a long lasting, you know, they were pretty thin steel, but I wanted to test it and see how it worked. So it was basically an in-ground thermal mass rocket furnace, and it actually worked pretty well. Obviously, since then I've gone to the wood stove and water inside and all, which I have to say I like. But it does take up a little bit more floor space in the greenhouse. That was why I originally designed this like this, in combination with wanting to test an in-ground furnace and thermal mass that way. Anyway, I'll just show you real quick the tube that comes out over here. This is where the greenhouse smoke used to come out, and I had this pole up here about 15 feet in the air, and it didn't matter, because that smoke would come out so cold, it would come out the top of the tube and settle right to the ground. And I did get some testing done playing around with using that as a wood gas generator for running a generator. I did manage to get flare off of that. I'll see if I can dig that clip up and maybe I'll throw it in here quick, but you'll see the flare that I was able to get off of this. Eventually I want to do something like that again, sort of a rocket furnace combination wood gas generator, basically run an engine and use the excess heat from the combustion of the wood to heat the greenhouse, or to heat, ideally it would be like an aquaculture pond. Anyway, so I've realized I've neglected this over here. The water line also comes in here. There's a T underneath this from the ram pump, and you can see that DS18B20 sensor there. I believe that sensor's bad, but I got to get back and actually test that. And so I'm going to probably set this up so I can get at this. I'll probably drop some kind of a channel down here so I can get to it to work on it if I need to. And then I'm going to fill in here where the soil settled in a bit. I should mention the frame of this whole in-ground stove is built with really high quality steel. Those are actually bed frames, and if you've ever tried to cut a bed frame with a Sawzall, it's nearly impossible. That stuff is super hard. So that was to maintain structural integrity, knowing that in the future the furnace would kind of collapse in on itself. Same thing in the back underneath the beam here. You can see this beam is rotted, and you can see I overshot that beam significantly to catch on the firm soil over here, because obviously when we disturbed this, the soil wasn't going to stay. I knew it was going to settle. So over time that's rotting down and breaking down. So what I'm going to do is come back here. I'll probably stuff another piece of log underneath this to kind of block that air hole up, and then I'm going to fill the rest of this in level with soil, and I'll probably cut off the top of the structure here so it's not sticking out. And then after that I'm going to come around with more wood chips. I'm going to go right around this end, and I'm going to wrap in right up almost to the pool, and just make this one tight greenhouse. We're going to go right up to the insulation height again all along it, and that should really make a huge difference in heating and make my thermal management much easier. This is something that I should have gone back and done quite a while ago, but I kind of got sidetracked building Raspberry Pis and thermal mass management systems, and you know, there's no shortage of ideas or projects for me ever. Anyway, so this is working out really well. Just since I did this and came back with a shovel and mounted this up, it is like, it's 80 degrees in there and humid, and you can feel there's no air like flowing in or out. It's, I don't know, it's like 40 some degrees out tonight. It's not super cold, but usually on a 40 degree night you'll feel that cool air coming in. This has tightened it up tremendously, and I can't wait to finish the whole wrap. I think we're going to be set for no matter what kind of cold winter gets thrown at us, we should be pretty solid. So I'm really stoked about it. I just thought I would share it. Sorry this is at night, but I'm really busy these days and there's not a whole lot of daylight and I can't burn it. So thanks for watching the Pharmacy Seeds Network.